Well, good morning, everybody. I'm Gordon Mackerron. I'm going to give you the pre-welcome before I hand over to Sarah, just to let you all know this is going to be recorded. If you have questions, there will be time at the end of the presentations, but if you want to post them now in the chat box, Rhiannon will collect them, make sure that it's clear later on. Thank you all for being here. Let me turn over now to Sarah to give you a proper introduction to the week. Please, Sarah.
Thanks very much. Great. Can you see my main screen or presenter screen?
You can see your presenter screen.
Oh, let me switch back.
Yeah, that's perfect, yeah.
Can you see the main screen now? I've got two screens going and I don't know which one you can see, sorry.
Do what you did before and it was perfect.
So are you seeing the presenter view or the main view?
Slides at the moment.
Can you see it full screen?
No, you can see just your slides at the moment.
Is it full screen now?
Yes, perfect.
Sorry for that delay. Right, so thank you very much everybody for joining this morning. My name is Sarah Walker and I'm Director of the National Centre for Energy Systems Integration. So just to let you know that there's a range of things going on this week in terms of our events. We have a couple of things going on every single day. So it's really great to see people joining us for this session and hopefully for others as we move through the week. We wanted to take this opportunity as CESI comes quite close to its final end date to really celebrate what we've managed to achieve over the period that CESI has been running. Part of that celebration is posters as well as presentations, and some of our presentations and speakers are from our industry partners as well as the research colleagues that have been involved in CESI while it's been running. We wanted to also showcase a little bit of the work that we've been doing with demonstrators during CESI, because we see that as a relatively unique part of what we've been doing. And we're actually meeting face-to-face on Friday as well. So for those of you who are joining us on Friday, we really look forward to welcoming you to our site visit on Integral, as well as our range of speakers that are happening on Friday. So just thinking back then, CESI originally was established to address issues around integrated energy systems in the UK. We felt that the current limitations on modelling meant that those limitations prevented the existing tools from being able to address integration. And so we put forward a proposal that tried to address this to ensure that we could investigate the potential for robust, secure, flexible and affordable future energy systems. So we wanted to reduce the risks and uncertainties surrounding a fully integrated energy system in the UK. We wanted to develop holistic models, simulations, and optimization methodologies. And we wanted to use some full-scale demonstrators to help us better evaluate the above mentioned tools and models. So the demonstrators have been an integrated part of the research. And then the principle then was to use that research to inform policy and government decision-making. Our team has grown since our original launch because we've had a flexible funding mechanism to bring new partners in, and that's helped us to add skills and disciplines and partners to the consortium. Our industrial partners have been a key component as well. So many thanks to Siemens, Northern Gas Networks, Northern Power Grid, National Grid, Ørsted, GHD, TNEI. There are lots to mention. But on that research to inform policy and government decision makers, some particular examples for us to feel proud of are some work we've done on post notes, on policy briefs, on written evidence to government, and some of our research has been referenced in key government documents. So in terms of some of our outcomes then, one thing that's worked very well for us is co-hosting conferences. So we've co-hosted UK Energy Storage in 2018 and 2019. We co-hosted the International Building Performance Simulation Association Conference in 2020. And we were involved in the Institute for Energy Systems Integration in 2017 International Conference. And that International Institute for Energy Systems Integration morphed into the Energy Systems Integration Group, and we co-hosted a conference with them in 2019. So lots of outputs by way of journals, policy impacts I've already mentioned. Our 9 demonstrators we've engaged with significantly over the period, and we continue to develop industry and cross-sector collaboration. We're really excited at the development that we've seen of our staff and students over the time that we've been working. And we're delighted to be able to host this conference and identify some of our key highlights that we're sharing over the week today. So thank you very much. I'll hand back to Gordon.
Sarah, thank you very much. We're going to have a set of 1, 2, 3, 4 presentations this morning. The ambition is to make sure they don't take longer than about 10 minutes, so there'll be a chance to have question and answer and general discussion at the end of the session. Just as a discipline for myself, I shall try and make sure I stop within 10 minutes. I will encourage the others of you who are going to present to do the same if you look like overrunning very much, but hopefully that won't be necessary. So again, my welcome. I'm going to try and share my screen. I know that Rhiannon is here as a backup if necessary. That's sort of all right. Let me just check. Is that visible to people?
Yes, that's visible. If you could just go into presenter mode as well, that would be great.
I'm sorry, I'm not sure how I do that.
Yep, just on the bottom.
Yes.
Yep.
Which button is it? Sorry, I apologize. I'm still not sure what I'm meant to be pressing, sorry.
Just next to you see the minus and the plus button in the bottom right, the one to the left of that. Keep going, left, 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 left. There.
That one?
Yeah.
Oh, no.
So just the button left of the minus sign.
I apologize.
Or if you can press F5, that might work.
Sorry, F5 did you say?
Yep, try that.
No, maybe the easiest thing will be, Rhiannon, if you could, if I'd get rid of my screen share, if you could do it for me, that would be a big help.
Okay.
Okay, if Rhiannon, you could put on my first main slide. I apologize for the delay.
Okay.
Yeah, if you could move to the first main slide after that, that would be good. Thank you. Okay, it's impossible in 10 minutes to say what we've done over 5 years in one particular work package. I'll make some introductory remarks and then say something about scenarios, which have been a major topic for work package 1, which, as you can see, is commercial, regulatory and policy aspects. We in principle covered all of the social sciences, and that included a substantial contribution from anthropology, which, although not unique in terms of looking at energy systems, is still relatively unusual because normally it's a fairly technocratic approach. So the notion was that we would use the social sciences and see how we could combine them with other engineering and modeling approaches, which have been the dominant issues within CESI. As time has gone by, not everything easily got classified as work package 1, and that was all to the good because we didn't want the work packages to be individual silos. So we've collaborated more and more in projects and sub-projects that aren't easily classified under a particular work project number, work package number. Clearly, we had a big focus across CESI on energy modeling and what I've called its discontents, which I think Sarah has just outlined briefly as well. And we were very conscious that the huge ranges of uncertainty when we look forward to 2050, which became an increasingly important date over the period of the project, was something that we had to tackle in a whole variety of ways. And we tried that largely through scenarios within work package 1. Rhiannon, if you can move me to the second main slide, that would be very good. Thank you. Social scientists are often, as it were, the grit in the oyster. We ask some awkward questions. One was we didn't want to make an assumption that integration was always and automatically a desirable property of a future system. We had to think about whether or not integration might hasten system collapse. One part of the system being faulty might have been transferred to other parts as well. The other issue, which I think was more important in some respects, was that integration seems to imply some notion of centralization. Things are being combined together in larger units. But a lot of the technology evolution in recent years around energy systems has been small scale and has appeared to be encouraging decentralization rather than centralization. And that's a dilemma which is not easily resolved. We spent quite a lot of time looking at how decentralized approaches could be useful, knowing that aggregating them up into a national picture would be quite difficult. The trilemma Sarah already mentioned: security, affordability, and sustainability. Over these last 5 years or so, we've also had the rise of something that people have often called the 4 Ds: decarbonization as a kind of given, digitization as something that's clearly happening, decentralization I've already mentioned, and hopefully, especially with decentralization, a higher degree of democracy in decision-making, because historically, energy decision-making has been very technocratic and very centralized. But this question of how you aggregate from decentralized action to meet a nationally determined target, a net zero target for 2050, is clearly a major issue. So coming on, Rhiannon, if you could move to the next one. So uncertainty and scenarios. As I've said, modeling energy systems traditionally dominated by techno-economic approaches, and they're usually optimizing approaches, and they have great value, and they're necessary, but they also miss things out. It's generally true that what gets modeled in such approaches tends to be what is relatively easily quantified. And most of the models that we saw as we started don't handle discontinuities at all well. And uncertainties tend to be treated in rather limited and sometimes rather mechanical ways, even though we know they're pervasive. So a classic social science approach was to try and handle via qualitative scenario development. And just one other point I should mention about the way in which traditional modeling takes place: it often makes the assumption, and for government this is something that it feels it has to do, that the decarbonisation commitments will be met, that there will be net zero by 2050. And we know that in the real world this might not happen. And if we don't try and examine what are the possibilities of it not happening and what those consequences might be, we may be in some sort of trouble. And of course, as academics, we weren't constrained by government's need always to project the notion that decarbonisation targets will be met. When we looked at the scenarios that have been done historically, we discovered that, I have to say somewhat to my surprise, past scenario exercises done through UKirk and UCL looked at scenarios between 1978 and 2002 and then said, how did they turn out? How far were they in any way reflective of the world? And what was remarkable was that the way the real world turned out was more often than not outside the outer bounds of even some quite numerous scenarios that appeared to cover a wide range of possible futures. And that was quite a salutary lesson when we started off. So let me talk now just briefly about our approach to scenarios. And I'm being brief partly in the interest of time today, but also because Claire Copeland, who I think is on this call as well, we'll be having 2 further sessions later in the week in which she will go into somewhat greater detail about participatory ways of managing scenarios, and also a case study of the north of Tyne region, which we took as our regional example. So we started, when we were looking at scenarios, at Findhorn, a community that many of you will know about in the north coast of Scotland, which quite a few members of the CESI consortium had already been studying at some length and had a good relationship with. And we constructed a 2x2 matrix. Classic way of doing scenarios, which I think is very useful, is to look at what we think are going to be the most important drivers of change for the future. And this can be done in participatory, at least partly democratic ways, by getting stakeholders and potentially citizens as well to give us their views, their informed views, wherever possible. And those 2 drivers then in the combination can easily be moved into a matrix of 4 potential future scenarios. This allows quite rich narratives to be constructed, and they're easily elaborated in some ways, and they allow a more imaginative approach to the future. Hopefully, this sort of effort gives serious indications of the robustness of present decisions and actions by showing those things that seem to be doing well across all scenarios and those things that do not. And of course, it pinpoints the sort of uncertainties, the sorts of differences there might be for different kinds of futures. But we were well aware always that there are quite a lot of risks in this enterprise. The risk of developing purely qualitative narratives that are, first of all, difficult to test quantitatively, and if they are tested, turn out to be implausible or virtually impossible because of various kinds of physical or other institutional constraints. We then spent quite a lot of time in CESI looking at the ways in which it might be possible to combine soft linking, I think was the way Sarah described it a few moments ago, combine these kind of narrative qualitative futures with the kind of quantitative modeling that was a major activity of CESI as well. And I'm not going to say that we did this with huge success. We have done, I think, some good work in this area, but it's an inherently difficult area. It's one that I'm sure everyone will hear more about both today and later this week. But I'm going to leave it at that in the interest of time. I'm very happy to take comments and questions on this, which we'll leave to the end of the discussion. So I think I've kept to about 9 minutes. Thank you all for listening to that part. We're going to move on now. I think it's to either Simone and Antti. Simone, are you going to kick off? This is going to be about control rooms of the future.
I will do. Thank you very much. I'm going to share some slides as well. So thanks very much for asking us to speak. Antti is with me, but unfortunately he's pretty much lost his voice. So he can look after the chat and I'll do the talking, if that's okay. So we wanted to present, or we were invited to present a sort of sub-project that was funded through the Flex Fund part of CESI, where we wanted to think about control rooms of the future. And this came out of some discussions at the demonstrator, actually, in Integral, about what would happen if you tried to integrate, in particular, or coordinate at least, electricity and gas distribution systems. And this comes out of a question around the role of hydrogen as a storage material, which obviously itself, if you're going to use hydrogen to hold energy from electricity and potentially either use it in the gas network or to go back into the electricity system, you have to think about how that's going to work at the distribution level. And that's partly because of what Gordon was saying about increasing decentralization of energy systems. The distribution network operators are becoming a more significant element of the energy system, and that's reflected in their new designation as distribution system operators. So we were interested in a number of questions, firstly around the kind of regulatory and institutional conditions for the different energy factors, not least because current market rules mean that electricity and gas distributors are not allowed to cooperate because that's anti-market. So how then can you integrate them? So that's one level of kind of issue that needs to be dealt with. Another is just thinking about what a control room is like, we know that all workplaces in different organisations have different ways of doing things. That's as true for universities and companies as it is for energy systems operations. So we were interested, actually, you know, the people in the rooms who wanted to bring them back into the question rather than thinking just about the technology. And then some, you know, thinking a little bit about some of the risks. So we worked alongside Andrew Wright, who was on the board of CESI and who is now a professor in practice at Durham University, who obviously has experience through Ofgem around the institutional and regulatory issues. So he provided a great deal of background information and advice on regulatory questions. And then our kind of core methods from there were to actually go into some distribution control rooms and see how people work there. And we did a number of observations of gas and electricity distribution network control rooms. And then we invited all the participants to a workshop where we could discuss what we'd seen and what we'd observed and what we concluded from those observations. And a number of things came out of this. One was that, I mean, there are a number of interesting findings. What we find is that obviously there's a lot of similarity. Distribution control is distribution control, but there are different operations happening in the gas and electricity network, in particular when it comes to things like forecasting, which is a major occupation in the gas control room, but not so in the electricity, for example. And obviously the shape of the networks is very, very different. The kinds of technology, the complexity and so forth look very different in the different sectors. Although at the same time, there's a lot that brings them together. They use the same sort of information systems, for example. They use quite similar, but not exactly the same approaches to managing maintenance between a control center and site, between different maintenance operators working for them and so forth. And one of the things that we were very struck by, and this came out of a workshop that we were invited to on energy histories, was about the role of flexibility. And obviously throughout CESI and throughout thinking about integration, when we talk about flexibility, we tend to be thinking about flexibility of the kind of physical equipment in the energy system. And it struck us that there was another kind of flexibility that was very clear in the control rooms, and that's the flexibility of the control room engineers to think on their feet, to use the equipment and the skills and the systems under their control in a creative way to respond to things like emergency situations or breakdowns or unusual maintenance issues or discrepancies between what's coming through the information system and what the engineers on the ground are telling us, or telling them rather. So the kind of skills in the and their creativity and the flexibility that the operators, that the engineers bring to the system is really not to be overlooked. And that, I think, is particularly important because there's so much more discussion about automating distribution networks as if all the equipment is reliable and predictable, whereas we're talking about networks that have equipment that, you know, comes from different times, basically comes from different eras. There's material out there on the ground which can be 30, 40, 50 years old, some of which is networked, some of which is not networked, some of which is standard, some of which is non-standard. So you can't actually automate everything, and certainly not at the moment, and certainly not without extremely significant investment. So we certainly see that the sectors are very distinct, that they have some commonalities. What was very striking for me was that none of the people working in the control rooms had been in the control room of the opposite sector. So none of the gas control room people had even been in an electricity network control room. And they were quite interested in visiting each other. But I mean, that's for the market distinction reasons, that's very difficult. We're not supposed to have a lot of contact, but I think that is an area that could be investigated a bit further. One of the competition problems is around unfair advantage, but what was very striking was that in both cases, what they're doing is delivering from the transmission system to the supply system. Neither sector had actually any contact with the market operations of their organisation. So they're already very kind of technically focused, which made me think that perhaps those market regulations need to be really thought a bit more carefully about in what kind of cooperation could be feasible or allowable. And in a kind of more reflective sense, when we're thinking about control rooms, it's very clear from the beginning that what constitutes a control room is up for question. We were thinking initially about the people sitting behind the arrays, making the decisions and operating the system, but obviously that control room is just one small part of a much wider network. Obviously the connection between the control room and the people on the ground using electronic information systems and telephones, and in some circumstances fax machines still, interestingly. But also there's all the support networks around the control room, there's all the planning, there's the kind of larger network of operators within the network distribution control, which can be thought of as part of the control room or part of the control operation. So just thinking control room is not quite as straightforward as it might initially sound. So just finally, we've published one or two things. As I said, we took part in this very interesting workshop at Lancaster on the histories of flexibility, which has been published in the Journal of Energy History, most of which is about the other kind of flexibility, the technical flexibility, whereas we were thinking about the flexibility of the people involved. And I also just make a note that we did rely on this prior publications of Andrew Wright about thinking of system change and integration in context. So if you have any questions, please feel free to share them with us.
Sarah, thank you very much for taking exactly 10 minutes. One of the things we're trying to do today is to look at different ways in which control rooms are important in relation to future systems integration. And we will now move, and thanks very much again, Simone. I'm sorry, Anta, you've lost your voice. Could we move to Mudita, who's going to say something about the control room project that was another Flex Fund project from the University of Cardiff. So welcome, Mudita, and go ahead. Yeah, Mudita, please start. We can see your screen.
I can't hear you.
Can you hear us?
Can you hear me now?
Yes.
Okay, sorry for that. No, thanks, Gordon.
Okay.
I think my mic had to be replugged in. Anyway, good morning, everyone, and thank you for inviting us to speak today. So I'm going to actually follow on another Flex Fund project funded by CESI. So my name is Mudita, and I'm a lecturer at Cardiff University, and I'm presenting on behalf of the team. Satsara is another PI of a Flex Fund project who did the continuation of this work. So just to give a bit of background, we were awarded 2 Flex Fund research grants from the CESI to develop a decision support tool that translated some of our academic research in the area of improving facility energy management to a functional tool that can be used by facility energy managers, particularly focused on the public sector, looking at the operation and performance improvement of their on-site energy systems. So we build on partnerships with 2 case study sites, estates officers at the Queen Elizabeth Hospital in Kings Lynn and also the University of Warwick campus. So those were our case study sites. We were also supported by the UK Cabinet Office. The Crown Commercial Service lead, John Nangle, was an advisor throughout for the project. We were also supported by the local DNOs for these two sites, UK Power Network for the Queen Elizabeth Hospital and WPD for the Warwick site, and also the control solution suppliers. So really something to say about these two projects was this was an opportunity for us to bring together the key stakeholders that involved in moving these facilities and sites through the energy transition, making them from passive to active sites. So to say, the public estate is made up of a large number of assets ranging from hospitals, schools, prison complexes, business and innovation parks, administrative offices, and these are spread all across the country, as you imagine. And public sector, for those who don't know, is the largest single buyer of gas and electricity in the UK. It consumes over 6% of the UK's energy supply annually, and the government spends over £2 billion per annum on its energy bills. So outside the big six energy suppliers, the public sector is a major aggregated consumer of gas and electricity. So typically, public sector estate includes large campus scale energy systems such as hospitals and universities, who are typically large users of power and heat. So these two sites which we investigated, shown here, the top figure is the Queen Elizabeth Hospital site, and the bottom is the University of Warwick campus. They both had a similar structure where they own and operated the on-site energy system, a multi-vector energy system behind the meter that included a combined heat and power plant, energy centers, gas boilers, backup generation, and increasingly renewable generation, such as solar PV and wind turbine, and energy storage within the campus sites. So these sites were operated behind the meter to try and primarily reduce the energy cost, but with an increasing interest in reducing carbon as well. So collectively, across the UK, these sites aggregate to significant scale, and any changes, any of their operational practices impact the local network. So we started off by bringing a number of facility energy managers to try and understand some of the main challenges that they were facing on their day-to-day jobs, and also looking at the future transition of the energy systems for their sites. First of all, energy was, one thing to recognize is it's only one of many priorities for these organizations, and often it's system resilience much more than the energy efficiency or carbon impact is what's important. And secondly, there was an aged infrastructure and lots of obsolete equipment in many states, and across the public sector, they were severely constrained financially to make any improvements, so were reliant on grant funding to make any improvement actions. So those were some of those common challenges, but when you go into more technical challenges, there were problems around using the gas-fired CHP, which were no longer a carbon-saving technology, having to make decisions for low-carbon technology, conflicting systems being added to on-site infrastructure, local DNO constraints were prevalent. So these were discussed in one of our workshops, which led us to what we worked on in the next stages. So these campuses, as I said, are now moving from being largely passive consumers of electricity and gas, and due to their ambitions of being net zero organizations, to have a much more active role in the power system operation. But the energy management system, what we recognized, was still based on very simple rule sets just to meet the on-site energy requirements, and needed a significant improvement, significant understanding from the local operators to move through this transition. And another learning in this project was the complexity of the stakeholder ecosystem that a public sector estate office has to manage in its energy interaction. So this is just a diagram we constructed to create this picture of the numerous commercial arrangements, commercial contracts that an estate energy manager has to be on top of. And that includes building energy management systems. If you are managing a battery storage and other flexible assets, the interactions with aggregators, the software reporting services for carbon and energy reporting, energy consultancies, and if you are, and with the DNO for the grid constraints, if you have a energy performance contract with the ESCO, so forth. So we set out to bridge the gap between the academic research that we found to be relatively disengaged with the realities of the ground of a organization, and provide accessible, user-friendly decision support tools that can consider multiple objectives of a public sector organization. So one of some of the criteria that we set was that they need to have non-onerous initial data requirements and need to capture these multiple stakeholders and contractual relationships that are available on site. So that's so to give a very high level overview, the support tool framework which we have set out to develop. First, starting from a very simple energy flow based mathematical modeling approach that quantifies the site operation as it is, and also being able to capture the improvements into the future in terms of energy costs, carbon on the site. And this was facilitated by creating, again, a very simple, so we use the term digital twin, but a very simple way to represent the energy management of the site and what would be the impact of new technologies, and then to influence what the improvement opportunities are. We also leveraged our work from Energy Rev project to look at investment options for such sites going into the future transition. So that's just sort of an overview of what the framework and the data flows for the Queen Elizabeth Hospital King's Lynn look like, where we quantified what the data inputs that were required, and also showing a built business analytics dashboard, which we made available to the hospitals and the university campus in Warwick. So just to as some final steps, so we've had really good response from our projects. So we have very good feedback from the Queen Elizabeth Hospital, who really enjoyed the work we did and are influencing some of their BMS upgrade programs to use some of our learnings in their programs. We have now also initiated conversations with Rotherham Hospital to actually extend that work, and also looking into commercial opportunities to commercialize this tool. So just to leave final few key messages. So public sector, we have focused on the public sector, which has great promise to lead the decarbonization agenda. We recognize partnerships are key in this journey, and decision support tools for these facility managers are absolutely key to help this transition process. I'll leave it there. Thank you very much. For any questions later. Thank you.
Mudita, thank you very much. It whets our appetite for more results, which we can't quite manage all today, but there may be some interesting questions for you. So again, thank you very much for that extremely interesting presentation. We will now move to the final main presentation, which I think Jamie Stewart is going to give us on behalf of Karen Turner about Net Zero Principles Framework. Jamie, whenever you're ready, please go ahead.
Thanks, Gordon. And good morning, everyone. Hopefully you can see my screen there.
We can.
Great. Hopefully it's just going to full screen. Great, thanks. Well, yeah, good morning, everyone. And thanks again to CESI for the invitation to show what we've been doing in one of our Flex Fund projects focused on the electric vehicle rollout. As Gordon said, I'm presenting this morning on behalf of the project leads, Professor Karen Turner. My colleague, CESI, will also be doing the sort of second half of the presentation and presenting some of the results from the project. So the Centre for Energy Policy, we're a multidisciplinary research centre based at the University of Strathclyde. We sit within the School of Government and Public Policy. But we are largely a group of economists. We're made up of economists, an energy system modeller, and knowledge exchange staff. And we're very much focused on looking at the economy-wide impacts of different climate and energy policy actions. And also looking at trying to build up that political narrative development. Our work today, as I said, will focus on our project looking at the impacts of the electric vehicle rollout, but we look at other policy areas such as carbon capture and storage and energy efficiency. And all of our results are really set in that wider public policy context. The type of economic modelling we do is a dynamic model. It's similar to the likes that the Treasury use, looking at how actions in one sector impact across different economic indicators like employment and GDP. But we also very much look at sort of impacts on different distributional impacts, the impacts on different household groups and things like that. And CESI will talk a little bit more about that in the next few slides. So our mission at the centre is working to ensure that mid-century net zero targets deliver sustainable and equitable prosperity. We know this is something we're going to have to deliver over the next decades. It's ensuring that we do that in a feasible way that, as the slide says, delivers sustainable and equitable prosperity. At the centre, we've developed a number of net zero principles, which have really been drawn out of our work across a range of different projects. So number one, we think it's crucial to understand who really pays, how and when, and that's the type of thing our economic modelling allows us to look at. Crucially as well, understanding where benefits might accrue. This is the type of thing that the Treasury's been very clear on, that there will be challenges and opportunities in delivering the transition. Number two, again, making sure that we grow our prosperity in an equitable way, ensuring that there are near-term economic returns where possible. Number four, we think that offshoring is not the answer if it shifts emissions, jobs and GDP overseas. And number five, which is probably the most important one, we think that net zero really is a social and public policy challenge more than a technological one. And that will hopefully be evidenced in the rest of our presentation. So along with our net zero principles, we've also developed a net zero principles framework that really is designed as a tool to help policymakers understand some of the implications of different net zero actions. And this is split between something that we call the enabling stage, an interface stage and a realising stage. And this work is summarised both in a policy brief and in an academic paper. So again, on this slide, we show how these different questions in these different stages can be used to prompt thinking and collaboration about different implications of different actions and different trade-offs that might be involved. So the enabling stage is really about action that is used to enable a wider set of implications. So if we take the example of electric vehicles, the enabling stage would involve reinforcing the electricity networks to allow electric vehicles to be charged. The realising stage is more about how the rollout of electric vehicles in themselves might impact different economic and societal outcomes. And obviously there's an interface between the two as well. So hopefully that provides a wee bit of context. I'll pass over to my colleague Faisal, who's going to talk about the project specifically that we looked at on electric vehicles and how we used that net zero principles framework to frame our research.
Thanks, Jamie. I'm Olorse Alabi, researcher at the Centre. So I'll just follow on from what Jamie has just presented. I guess in the example of just taking a few examples here, and particularly our recently completed Flex Fund project and looking at the impacts of the rollout of electric vehicles in the context of net zero. And just looking at that in the context of the net zero framework, principles framework, I think for the enabling and the realizing stage, for the enabling stage is more about the laying of cables, the range of activities around that, and then the construction activity going on around that period as well, and then how this investment will work and how the recovery of that investment will work, and how that will also impact the price of electricity and the prices within the economy. And then when we move to the realizing stage, it's more of the progressive shift between when you move from the conventional vehicles into, I guess, the rollout of electric vehicles, and then the changing of fuels from petrol and diesel to electricity, and then looking at efficiency gains, and then having to try and just tie it together to see how the interaction between this stage impacts the wider economy and how the economy might respond. Jim, please can you go to the next slide? Okay, thank you. So I guess this is just an example from our project, just to give you a framing towards this enabling and realizing stage. I think when we look at the enabling stage here, I think I should mention that the model we use here is an economy-wide computable general equilibrium model. And I think that's informed by an energy system model. We have taken information from that to, I guess, in some way, soft link to get some of the technical information we need to run our analysis. And I think from the energy system model, we have got an estimated 10 billion required to upgrade the network if 100% of EVs are to be rolled out. And I think our starting assumptions, or the assumptions we have made, is that of this 10 billion that needs to be invested to upgrade the network, 1/3 of it is going to be spent within the UK, and the 2/3 left will be what will go to imports. However, all of UK consumers will need to pay the cost of recovering the investment over the lifetime of the assets, which in this case is 45 years. So if we just look at the chart in more detail, we realize that there's this very great climax or increase in the price of electricity, which is the blue line. And that's because of the passing of the cost of the recovery of the investment through the increase in the electricity price, able to cover that. However, you see that for the other macroeconomic variables like GDP and real household spending and earnings, you see that it's just a very short period, just up to 2035, where there's some very time limited and gains. And after that, you see that there's a drop. And that's because there's just some stimulus because of the construction activity. And once that activity is gone, there's really nothing else driving or boosting gains within the economy until after the recovery period has ended, which in our case is around the 2090s, when things begin to smoothen back into the equilibrium phase, where things become probably back to equilibrium. So I think the main thing to draw out in the enabling stage is that there's just a time-limited boost and increase in the economy-wide impacts, but it's not long-lived. Jamie, I don't know if you go to the next slide, please. So compared to what we had in the previous picture, which was just the impacts of the rollout of the investment and some of the technicalities around that, in this slide now, we just present when we bring in or introduce the rollout of the EVs. And like I said, this is the 100% case. And I think Gordon also mentioned this previously, that we have also considered a 50% EV rollout case, where you have invested for the whole 100%, but you're not able to achieve that. But I will encourage you to read our paper to see more about that, but we just focus on the 100% case here. So with the 100% case, we see that, well, the economic gains are quite different. There's kind of sustained increases that we can see. There's still the increase in the price of electricity is kind of more than we had in the previous time. And first, this is because also of, having to repay the investment. But I think the issue here is that there's a sustained increase in the price of electricity and the CPI. And the CPI in this case is what we use, or an indicator of the cost of living. And you see that because of the increase in the demand for electricity to fuel EVs, that's one of the impacts why we have the sustained increase in the price of electricity. But on the other hand, it's because the electricity sector needs to kind of grow to meet that demand. So apparently there's also going to be demand on labor. There's going to be increase in labor costs across all production sectors as a result of that impact. Similarly, also, we see that there are increases in the real household spending, spending power is pretty increased here. We see that there's real earnings from employment. also in terms of their incomes and their take-home wages and things like that. But I think what we draw out is that not all households will benefit from these gains, even though they have invested or the returns from their investment or their capital investment. And in fact, not everyone might even benefit from it. So, which I guess brings into question some of the issues around the cost of living and how this might trigger other forms of poverty, especially for vulnerable households. Jamie, next slide, please. So I think the previous slides before were giving us the general overview of what's happening within the economy, particularly across the whole economy. But when we begin to look at the distributional impacts, we kind of looked at what we're focusing here now, what happens to different sectors within the economy. I think what's obvious from this graph is that the left-hand side, which I think is your right-hand side, is you see there's a lot of job losses or loss in employment there. And but on the right-hand side, there's probably more gains. I think what we have learned through some of our work we have been doing with CESI and more generally is that because the electricity sector is a domestic sector in terms of having a strong supply chain compared to petrol and diesel, which is probably more open to the pressures of a global market where that affects the prices and is probably more import intensive than electricity. We see that because of the strength of the supply chain of the electricity sector, there's a lot of gains in sectors like services, which we see where most of the employment gains are concentrated. Similarly, for other service sectors like education, accommodation, and the likes, there's increase in employment. And these are probably also sectors where households are spending a lot of their earnings on, and that's also leading some of the boost we're seeing here because of the shifts to increased demand for electricity as a result of the rollout of EVs. However, I think if you just go back again to look at what happens to, I guess, sectors in the left-hand side, for example, like chemicals and pharmaceuticals and also electrical manufacturing, which are more export-intensive sectors, we see they are losing competitiveness. And also the impacts of the increase in labor coming in as well is also impacting what we see happen to these sectors, which I guess is also another crucial question in terms of what happens to these sectors and also the offshoring question that Jamie highlighted when we're looking at the principles. Jamie, next slide, please. So just to bring it all together and just give some key messages and some of the things we have learned through our work, various projects we have done within the Flex Fund project with CESI. I guess first we know that the enabling stage activity in isolation only delivers time-limited wider economic gains. They are very temporary, and that's because of the construction activity going on during that stage. We see that there's sustained cost and benefits. There are benefits in terms of the gains in GDP and employment and the likes, but there are also costs in terms of the pressure on the price of electricity on one hand to be able to recover the cost, but also labor cost impacts are also coming to play because there's a lot of pressure on the sector to deliver. And we also find that there are policy challenges and trade-offs emerging in terms of, well, on one hand, like I said, the recovery of the cost, given that in this case, we have looked at it in terms of recovering through the increase in the price of electricity, but also there's also the issue that this is occurring within an economy where there's the presence of labor supply constraints. I think one of the key things we have identified through our research is that the question really is around, or the policy questions that emerge is really about who really pays and who really gains and how it actually balances or not against reality or expectation. So for example, if we take the case of who directly pays, like I mentioned earlier, because a substantial share of the network upgrade cost would need to be borne by all households, there's the possibility of unfavorable distributional outcomes, particularly for those who are vulnerable. And I guess, like I said earlier, these are crucial questions that policy needs to take into account, where this might trigger other forms of poverty or make people worse off or feel excluded in the process of having to transition to net zero. So I think I'll just leave it there for now. I'm happy to take questions as well. Thank you.
Thank you both very much indeed. Very interesting to see how economic and energy modeling can be used to look at social impacts, which historically has not been so common, but is clearly important now. So thank you to all presenters. I have to say, there's one thing that academics, we virtually never do, it's stick to time. So we should, I think, we'll congratulate ourselves this morning on having been very, very clear about how long we had. I think what we'd like to do now is to start with the chat box. I noticed there are 6 items in the chat box, and if we could go through those one at a time, we could then ask for more general comments or questions. So if people are happy to look at that now, can we start with Helen Stockton's question, which I think Antti and Simone may have answered, but perhaps if any of you involved in that could just briefly outline for us what it is that you're saying there. Either Simone or possibly not Antti, or Helen.
Yeah, thanks. I think, well, I was interested in the way that Helen raised the question of consumer flexibility, which is often seen as a kind of demand, or sorry, I can't use the term demand in this in this context because it has such different meanings, but the idea that somehow the solution to energy system shortcomings is that consumers should be more flexible. And in a way, I think what we're seeing at the moment is the limits to consumer flexibility, because there's so much pressure on consumers at the moment who can't afford to consume in the way that makes their life livable. So Helen was kind of asking whether, one of the answers here is that distribution networks have to be more flexible. But one of the things about the control room is that at the distribution level, really the vast majority of their activities are around maintenance and repair. At the moment, there's not a lot of activity around balancing, for example, or incorporating different sources, although it does look like that might be coming, and it's coming in some distribution networks more than in others. So in the northeast of the country, there's a kind of oversupply of infrastructure because of the industrial history, whereas in other areas like the southwest and some parts of Wales, there is a lot more activity there going on about incorporating new kinds of flexibility into the network, into the distribution level rather than the transmission level. So yeah, these are very much areas to keep an eye on.
Very much. Helen, would you like to come in with any comment on that?
Yeah, thanks, Simon. Yeah, that was kind of my question in a nutshell. I suppose I'm coming at it from a slightly different perspective, in that at NEA we're principally concerned with domestic consumers and what the future of the energy system will look like and what the implications for consumers, and in particular the most vulnerable consumers, will be. And one of the things that we've been involved in discussions with for quite a long time is the role of consumers in being more flexible with how they use energy, shifting their energy demand or their energy use to different parts of the day, for example, or using energy in a different way at a different time, or different behaviours and practices. And I just thought the paper that Simon presented was quite interesting, because it's not in the control room is not really something that I've thought about before, and it just made me think about, are there other places within the energy system where we could introduce flexibility that might unlock efficiencies in the system, whereas previously when we've done work on flexibility, it's largely around flexibility of the consumer. But so yeah, my question was really about where else in the energy system can we unlock flexibility that might have implications for investment decisions, reinforcement of the network, etc. And what will the implication of that be for cost to the consumer further down the line, I suppose.
Thank you. I would just add that one of the key things that we think needs a lot more attention is around the regulation. The way that some of the regulations, well-intentioned, are actually making life very difficult for all of us. So that's something that needs to be looked at in some detail, I think.
Great, thank you very much. If I'm just moving down, there's, I think, another question from Simone. This was to Mudita. Would you like to say something, Mudita, about your response to Simone?
Yeah, sure. No, thanks, Gordon, and thanks. In CESI, actually, we were really focused on looking at benchmarking and providing baselines for these organizations in their energy consumption in much more granularity than they would get from looking at energy bills. But since then, we've actually moved on where, benchmarking baselines is the first step. And there's lots of challenges around energy data in these organizations for decision making. So getting a granular data set together for making good decisions was already a challenge. So what we've gone to do with these two sites is to build on that and look at operational and improvement that are low capital expenditure projects and what they may look like before going to consultancies and getting independent consultants for the organizations to have a better idea for what they could expect, so that they can get directly to detailed consultancies to do the work. And now we've actually taken that with in the Energy Rev project to look at investment options analysis for basically making those deep decarbonization actions like solar PV, or whether it's battery storage. So one of the challenges I think we've recognized is that suppliers that hound on these facility energy managers, they will try to sell anything, and to have their own organizational intelligence to make decisions is increasingly important. So that's where I think they really will find that value. Thanks.
Thank you very much for that. One of the themes that has struck me about both of the presentations about control rooms is the emphasis on old, obsolete equipment, some parts of which are incompatible with other parts. And when we're talking about digitization, even if the underlying new technologies are relatively cheap, we may have to graft them onto some pretty difficult old equipment, or the investment requirements are going to be very substantial if many of the benefits that both of the control room projects suggested would be delivered could actually be delivered. So that's just my observation. Going back to the chat box, is there anything else that we haven't really covered, or anything that anyone would like to say in relation to the questions in the chat box? After that, we'll open it to a more general discussion. We still have several minutes available. Anything else relevant to the chat box that people want to come in on? Either those who have spoken or things that are raised for other people?
Gordon, could I just comment, because what Mujita's saying was really interesting, and it overlaps quite well with probably what Claire might talk around about when she presents in the next later in the week. That the other project that we were working on around energy planning really showed that public sector organisations don't have the resources to adopt commercial or semi-commercial planning, well, not even software really, schemes. And so the ability for them to have a better understanding of their own campus is really valuable. And I can see that being very, very well used if it's not too expensive.
Anybody else on that subject, or any other in the chat box? I can't see everyone.
And now we've lost Gordon, so maybe I'll just step in and say, would anyone else like to make a comment or add anything to the chat?
I think just to respond to that, Simon, I think, yes, so that actually fits quite nicely with what we are currently engaged. How do we create such a tool that can be used more generically, not looking at individual sites, and make it a business process within those organizations, and how do we do it cheaply enough that it can actually be used as a service, for example. So that's directly what we are working on now as part of an extension to this work. Yeah, I'll look up Claire and see if I can join the session as well.
Oh, I was just going to, oh, sorry. We're in the same room, that's why. I was just going to say, I think we've totally lost Gordon now. So are there any more questions or anything anyone else would like to say? Nope. Can you mute yours?
Yes, if I could just ask a question. Do you feel we have enough emphasis on faults and breakdowns and emergencies? I'm working specifically with interconnectors between countries. And if that interconnector goes pop or we stop feed from another country, do we have a way to recover? Is that prioritized, do you think, when we have this modeling policy and investments? Do you think we emphasize that enough?
Who's that question for? Simone.
It's just a general, I mean, you can look at your public facilities where if the electricity system fails, we would go to emergency generation, or if we had a blackout, you would have a series, it would knock back so far on the breakers, and then we'd have a recovery where we would bring services back online. Do you think we focus on that sufficiently when we're designing these new grids?
It's partly a question for the economists, I suspect, that maybe Ken might have a comment on. Clearly at distribution level, that's everything that they're focusing on. So that's kind of the whole issue really about safety and security and continuity of supply and so forth. But I'm quite interested to know about the kind of, yeah, what's in and what's not in the economic models as well. So whether they account for the security, but also for the what's happening in other parts of the electricity system or the energy system rather than just the EVs. So I'll hand over to them.
Do you want to take that one, Sarah?
Go ahead, Jamie.
Yeah, I mean, certainly within our economic models, we don't. One thing that we do to try and understand our results is make quite isolated changes. So in terms of the work that we've done on electric vehicles, we very much model it on the existing electricity distribution system and look at what reinforcement and investment needed just for EVs would look like. So we don't look at how upgrade costs would be incorporated for things like faults or more interconnectors or anything like that. So unfortunately, I can't bring much insight into that one, I'm afraid. I think to Andrew's wider point about the resilience of the network, I think we've seen obviously with the fire at the interconnector this year and a number of plants going down at the same time, there has been real challenges around system security. I think National Grid, the electricity system operator, are obviously grappling with that. I think there is now more and more focus on system resilience, but whether it's enough in the future, I don't know. I'm probably not best placed to answer that one, I'm afraid.
Yeah, I could just add something, not being an expert in any way, but I think although we don't focus on the whole energy system when we're looking at EVs, for example, I think from some of our discussions with the distribution companies and some of the discussions we've had, the point is that I guess some of this costing is related to the price control periods, which we expect that to some extent should take account of these questions you mentioned in terms of determining what the cost might look like to retrofit or upgrade the network. So we expect that it should be part of some of those regulations and some of the, I guess, business operations of these companies anyway. So.
Does anyone else want to comment?
Yeah, I'll add some just from a hospital point of view, which we thought was interesting. So a hospital's energy infrastructure is primarily designed for resilience. So that's really everything they think about when looking at energy. And it's only now that carbon and net zero ideas are seeping, and it's that does contradict in some ways how they want to do decision making, and this is why it's a big challenge. But what we found also quite interesting is some of these investment might actually in the organization. So for a hospital, we look at having a large battery that allows them to manage their renewables were also an asset that was helping as a UPS for the hospital, critical energy equipment. So some of the brownouts they had, actually having that large scale battery on site installed actually helped them right through that. So there are those opportunities as well. So that's just looking at from an organizational point, and that's where I think some of these sites which were really focused on resilience at the local level have opportunities as they transition, of course, as challenges as well to really design. And that's where I think the lack of capacity resource is a real problem.
Thank you very much. Does anyone else have any last questions? You can use the chat or unmute yourself for any of our speakers.
Hi there, I just wanted to say I'll be referring to some of the Energy Futures work at various stages this week, tomorrow afternoon at 2 o'clock, and also discuss what Simone raised here. We did some looking at local government energy planning, so I'll be referring to that as well. And the Fintorm Futures will be in a poster presentation later this week. I'll be drawing a bit more on the insights altogether on in a speech on Friday. So just to get my plugs in there. Thank you very much.
Thank you, Claire. Then that leads me on nicely. If we haven't got any more questions, I'd just like to take this opportunity to say that we've got, as Sarah said, a whole range of events happening this week, including one later today at 2 p.m, focusing on energy supply, infrastructure and storage. And also to plug that on Friday, we actually have an in-person closing ceremony. So those of you that can make it, please do. Lunch starts at about 1. Just get in contact if you'd like any further details. Okay, so if there's no further questions, I'd like to thank you all for your time today and presenters. It's been very successful for the first event of the week. And I'll see some of you later on this week.
Thank you.
All right.
You all.
Thank you. Bye, everyone.
Bye. Thank you.
Thank you.